तो जय हिंद बच्चों, लेकर आ चुका मैं आप लोगों के लिए न्यूमेरिकल पोर्शन ऑफ स्पेसिफिक हीट कैपेसिटी एंड कैलोरीमेट्री का जो आपके पास मैथमेटिकल एक्सप्रेशन था, उस मैथमेटिकल एक्सप्रेशन के ऊपर इन तीनों चीज के ऊपर न्यूमेरिकल्स डिस्कशन करने जा रहे हैं। बहुत अच्छे तरीके से समझिएगा, बहुत ज्यादा इंपॉर्टेंट वीडियो है। यहां से आपके कहीं ना कहीं 3 मार्क्स कंफर्म होने वाले हैं। ठीक है, चलिए आइए फटाफट डिस्कस करते हैं। नो डाउट सबसे पहले हम बेसिक क्वेश्चन से स्टार्ट करेंगे, बट बिफोर डायरेक्टली जंपिंग टू कहीं ना कहीं न्यूमेरिकल, तो हम क्या करते हैं, आपको मैं एक बार फॉर्मूला लिखकर दिखा देता हूं। सबसे पहले आपको याद रखना है, चलिए हीट कैपेसिटी की बात करते हैं, ठीक है ना। हीट कैपेसिटी की, ठीक है, हीट कैपेसिटी को हम सी डैश से रिप्रेजेंट करते थे। इसका फॉर्मूला होता है क्यू बाय में डेल्टा टी, वेयर क्यू इज द हीट एनर्जी एंड डेल्टा इज द चेंज इन टेम्परेचर। आइए समझाते हैं। नेक्स्ट अब आपके पास स्पेसिफिक हीट कैपेसिटी, स्पेसिफिक हीट कैपेसिटी, जिसे आप सिंपली सी से रिप्रेजेंट करते हैं। जनरली छोटा सी होता है, अब बड़ा सी भी बोल देंगे तो कोई दिक्कत वाली बात नहीं, बट सी एंड सी डैश आप सिर्फ इतना याद रखें, ठीक है। ओके, नेक्स्ट है, इसका होता है क्यू बाय में एम डेल्टा टी, बस एम से ये डिवाइड हो जाता है और बाकी सारी चीजें क्या रहते हैं, सेम ही रहते हैं। आप इसको ऐसे भी रिलेशन भी आपको मैंने आप लोगों को याद पिछली वाली वीडियो में रिलेशन भी बताया था कि ये जो सी होता है वो किसके इक्वल होता है, सी डैश बाय में एम के इक्वल होता है। ये याद रख लें, नहीं तो आप सी डैश को याद रखें, एम टाइम्स सी के इक्वल होता है, याद हो जाएगा। मर्जी, आपकी मर्जी, कैसे भी याद कीजिए। उसके बाद जो कैलोरीमेट्री का कंसेप्ट था आपके पास, कैलोरीमेट्री वाला जो कंसेप्ट था, उसका जो मैथमेटिकल एक्सप्रेशन था प्रिंसिपल के ऊपर बेस्ड, वो ऐसा था, m1 c1 डेल्टा टी के जगह पे लिखते थे हम t1 माइनस का t, और बाद में जब हम m2 c2 और t माइनस t2 लिखते थे। क्यों? क्योंकि ये वाला टेम्परेचर t2 आपके पास कम हो रहा था, t ज़्यादा, यहाँ पे t1 ज़्यादा होता था, t कम होता था। यहाँ पे t1 इनिशियल बॉडी जो ज़्यादा हॉट टेम्परेचर पे उसकी बॉडी की बात कर रहे हैं, T2 मतलब जो कोल्ड मतलब टेम्परेचर का लोअर है उसकी हम बात कर रहे थे, और T है आफ्टर सम टाइम जब इक्विलिब्रियम में आ जाता है तो फाइनल टेम्परेचर क्या होता है। ठीक है, तो यही बस इतना ही कंसेप्ट आपको याद रखना है। बस इन्हीं 3 फॉर्मूले, आप इस रिलेशन को भी कंसिडर करें तो ये 4 फॉर्मूले कह लीजिए। इन 4 फॉर्मूले पे आज हम क्या करने वाले हैं, यहाँ पे न्यूमेरिकल डिस्कस करने वाले हैं। ठीक है, चलिए तो सबसे पहले हम बात करेंगे यहाँ पे इस वाले न्यूमेरिकल की। देखिए बड़ा छोटा सा न्यूमेरिकल लिया है यहाँ पे। इसमें कहा जाता है हमसे कि एन आयरन बॉल रिक्वायर्स दिस मच जूल हीट एनर्जी, तो आप फटाफट लिख दीजिए Q कितना आपके पास 5000 जूल। नेक्स्ट, टू रेज इट्स टेम्परेचर बाय 10 डिग्री सेल्सियस, 10 डिग्री सेल्सियस इसका जो टेम्परेचर रेज करना है, तो डेल्टा टी है ये। अब बात आती है सर ये डेल्टा टी 10 डिग्री सेल्सियस लिखें या 10 केल्विन लिखें या 273 ऐड करके फिर 283 केल्विन लिखें। आइए अब डायरेक्टली 10 डिग्री सेल्सियस या 10 केल्विन दोनों एक ही बात है, अभी समझा देंगे क्यों। नाउ वी हैव टू कैलकुलेट द हीट कैपेसिटी। हीट कैपेसिटी इज नथिंग बट सी डैश, और अभी आपको फॉर्मूला मैंने बताया कि जो सी डैश होता है वो क्यू बाय में डेल्टा टी होता है। बताइए हाँ या नहीं, सारी चीजें बता दी हमने। ठीक है, ओके, अब आइए हम यहाँ पे आते हैं। एक चीज ये तो समझाई देता हूँ मैं सबसे पहले तो आप लोगों को कि भाई ये जो चीज है, ये क्या नाम है इसका, कि ये जो डेल्टा टी है वो 10 डिग्री सेल्सियस दिया है तो 10 केल्विन के इक्वल कैसे हो गया। सर लास्ट वीडियो में जब आप रिलेशन बता रहे थे तो उसके इसमें ऐसा नहीं था, जब 10 डिग्री सेल्सियस की बात कर रहे थे तो 283 केल्विन हो जा रहा था। आइए उसका कंसेप्ट क्लियर कराते हैं। देखिए यहाँ पे ऐसा बिल्कुल नहीं बोला है कि जो टेम्परेचर हो 10 डिग्री सेल्सियस आपको लेना है, यहाँ पे ऐसा बोला है कि जो रेज किया टेम्परेचर बाय 10 डिग्री सेल्सियस, 10 डिग्री सेल्सियस से रेज हुआ है। तो अगर मैं ऐसा कंसीडरेशन में लेता हूं कि पहले बॉडी का टेम्परेचर मान लेते 30 डिग्री सेल्सियस था, तो अब वो 40 डिग्री सेल्सियस हुआ होगा, तभी तो 10 डिग्री सेल्सियस का चेंज आया होगा, रेज हुआ होगा टेम्परेचर 10 डिग्री सेल्सियस। सो हाउ यू विल फाइंड इट, यू विल फाइंड इट बाय दैट 40 डिग्री माइनस 30 degree Celsius, so it will become 10 degree Celsius. So that's how you find that what is the change in temperature or what is in raise in temperature actually, right? Okay, तो आपको ये और ये वैल्यू ना देकर आपको डायरेक्टली दे दिया है कि इतना 10 डिग्री सेल्सियस का रेज किया गया है, चेंज आया है बॉडी में। आइए अब दूसरे की अगर हम बात करते हैं, केल्विन के टर्म्स में, ठीक है ना, ये हो गया डिग्री सेल्सियस के टर्म्स में। अब हम बात करेंगे इन टर्म्स ऑफ केल्विन, ठीक है। तो इस केस में मान लेते हैं इनिशियली कुछ भी टेम्परेचर ले सकते हैं आप, कि स्टार्टिंग में जो टेम्परेचर था बॉडी का वो 300 केल्विन था। क्योंकि मुझे 10 डिग्री का चेंज 10 केल्विन का चेंज दिखाना है, 10 केल्विन का भी बता दे, क्योंकि 10 डिग्री और 10 केल्विन यहाँ पे बराबर है, वही मैं बता रहा हूँ आप लोगों को, इक्वल बात है। तो मान लेता हूँ मैं 310 केल्विन की बात करूंगा। अब इन दोनों के बीच का अगर मैं चेंज की बात करता हूँ, चेंज की बात करता हूँ, तो कितना आएगा? तो 310 केल्विन में से माइनस कर देंगे 300, सो इट विल बिकम 10 केल्विन। सो व्हाट डिड यू नोटिस हियर दैट if there is change in Kelvin और डिग्री सेल्सियस, both are the same thing, right? दोनों से 10 केल्विन का ही चेंज आएगा आपके पास। अब बात आती है कि सर 10 डिग्री सेल्सियस के हिसाब से बताइए, आइए वो भी एक्सप्लेन कर देता हूँ और अच्छे से क्लैरिटी होगी आप लोगों को। देखिए ये जो चीज थी 30 डिग्री सेल्सियस, उसको अगर मैं केल्विन में कन्वर्ट करता हूँ तो 273 में ऐड होगा, विच विल बिकम 300 केल्विन। ओके, बाद में ये चेंज हो गया 40 पे, तो और 10 ऐड कर 313 केल्विन। अब इनके बीच का चेंज निकालिए, कितना आएगा? दिस माइनस दिस विच इज नथिंग बट 10 केल्विन। तो आप डिग्री सेल्सियस में चेंज की बात करें या केल्विन में चेंज की बात करें, दोनों सेम बात है, वो चीज हमने आपको यहाँ पे एक्सप्लेन कर दिया। दैट्स वाई यहाँ पे डेल्टा टी जब लिखा है तो 10 डिग्री सेल्सियस बोल दें या फिर 10 केल्विन बोल दें, बात एक ही रहेगा। तो सी डैश निकालना है तो क्यू बाय में डेल्टा टी, तो यहाँ पे डेल्टा टी 10 है और क्यू आपके पास गिवन है कितना है? 5000। तो यहाँ पे लिख दीजिए 5000 जूल और डिवाइडेड बाय में टेम्परेचर कितना है? 10 केल्विन। केल्विन में लेना है, डिग्री सेल्सियस में नहीं लेना, ठीक है, ऐसा यूनिट के टर्म्स में, क्योंकि यहाँ पे दोनों इक्वल थे तो उससे कुछ फर्क नहीं पड़ा। तो वो कितना हो जाएगा? 500 जूल पर केल्विन। यूनिट आपको जरूर मेंशन करना है, वरना अगर 1 नंबर का क्वेश्चन हुआ, 2 मार्क्स का क्वेश्चन हुआ, तो ऑलमोस्ट हाफ मार्क्स तो मिनिमम है कि काटेंगे ही काटेंगे टीचर, अगर आपने यूनिट मेंशन नहीं किया तो। क्योंकि मैंने आप लोगों को यूनिट क्लियर करवा दिया है, तो बहुत अच्छे तरीके से आपको यूनिट जो है वो यहाँ पे मेंशन करते हुए जाना है। ये हुआ पहला न्यूमेरिकल। आइए हम सेकंड न्यूमेरिकल की ओर बढ़ जाते हैं। ये तो आपको मैंने फॉर्मूलेज बताए थे, इसकी ओर, ठीक है ना। अब इस वाले न्यूमेरिकल में क्या है हमारे पास? देखिए कहा जाता है कैलकुलेट हीट एनर्जी रिक्वायर्ड, इट मींस यू हैव टू फाइंड Q, will only use these 4 formulas, remember it, keep it in your mind, right? Okay, so we have to find here Q and which is required to raise the temperature of 2 kg, it means you are given mass, so mass is 2 kg of water, so here substance is water, or you can say the body is here water, from 10 degrees Celsius to 50 degrees Celsius. So here it is not given directly that what is change in temperature, but there are 2 temperatures given here. It means initially it was at 10 degrees Celsius, later the body temperature became 50 degrees Celsius. So now can you tell me what is the change in temperature? No doubt there will be 40 degrees Celsius. So how you will find it? So change in temperature is nothing but final temperature minus initial temperature. So it will come out to 50 degrees Celsius minus 10 degrees Celsius, it will be 40 degrees Celsius. Got it? Okay. So either it is 40 degrees Celsius or you can say 40 Kelvin. What do you say? Both are same because we have found change in temperature, right? Change in temperature is always same in terms of degree Celsius or in terms of Kelvin, both. Okay. Next, so delta T is also given here, so that is we found 40 Kelvin. We will always consider in Kelvin, which is SI unit of the temperature, right? Okay, now what we had to find? Heat energy, right? Heat energy required to raise. So heat energy, how can you find the heat energy? Here what we can use, the formula of heat. So heat energy is mc, or you can say Cm delta T, right? That's your heat energy, Q. That's what you have to find. Now what you need is, you need C, which is nothing but specific heat capacity. What is it? Specific heat capacity. Do you understand it? Heat capacity. So specific heat capacity of what substance? What's the body here? So body here is water, and we already know the value of a specific heat capacity of water, that I have already explained you in the last video, right? And I had written there 2 values. One was 4180 joule per kg per Kelvin. Another was we had just taken approximated value, which was 4200 joule per kg per Kelvin, right? तो ये कहानी हो गई आपके पास। तो आप कहीं ना कहीं आप सी की वैल्यू आप ये वाली चीज नोटिस कर रहे हैं, उसमें कुछ भी फर्क नहीं पता चलेगा, कोई टेंशन वाली बात नहीं है। तो देखिए यहाँ पे जनरली आपके न्यूमेरिकल में जनरली गिवन होते हैं, बट मैंने इस केस में गिवन नहीं लिखा। क्यों नहीं लिखा बताइए? क्यों नहीं लिखा होगा? कोई लॉजिक होगा? हाँ, लॉजिक ये है कि आपको याद रह जाए, याद रह जाए आपको। तो बहुत सारी चीजें एप्लीकेशन को एक्सप्लेन करने में काम आता है, जैसे कि मैंने आपको लास्ट वीडियो में बताया था, कई सारे एप्लीकेशन बताए थे मैंने आप लोगों को, राइट। तो उन चीजों के लिए आप इन चीजों को याद रखेंगे ज्यादा बेटर होगे। तो इसके जगह 4200 यूज कर लें। मास केजी में ऐसा यूनिट में रखें, आप सभी चीजों को 2 रखें, और डेल्टा टी इज नथिंग बट इट्स 40 केल्विन, राइट। चलिए मल्टीप्लाई कर दीजिए, 4 दूनी 8 को 42 से मल्टीप्लाई कर देंगे तो 8 दूना 16 के 6 बच गए 1, 8 चौके 32 और 1 33। सो इट विल बिकम 336 देन 2 and 1 3 zeros. That's your answer in joule SI unit. Okay, so that's your answer, which is nothing but the heat energy which is required to raise the temperature of 2 kg of water from 10 degrees Celsius to 50 degrees Celsius, or you can directly say that that's the amount of heat energy which is required to raise the temperature of 2 kg of water from 10 degrees Celsius to 50 degrees Celsius, or you can directly say in 40 degrees Celsius, to raise the temperature of that 2 kg water at 40 degrees Celsius by 40 degrees Celsius temperature, right? Okay, now next numerical number 3rd, it is there, a metal piece of mass 50 kg at 27 degrees Celsius requires this much amount of heat energy, right? Heat energy. So see, एक बॉडी था 50 ग्राम का था, इंफॉर्मेशन कलेक्ट करते जाना है, उसके बाद आपको काम कर देना है, ठीक है ना। ओके, ये भी बेसिक न्यूमेरिकल है, ये आपके पास क्या बेसिक न्यूमेरिकल है, कोई दिक्कत वाली बात नहीं। At 27 degrees Celsius requires this much in order to raise its temperature to this much. Calculate the specific heat capacity of the metal. So very easy question. First of all, we'll set the target. What's our aim? So our aim is to find the specific heat capacity. Now first of all, we'll write the formula, and from where we can find that value, right? So we'll write Q is equal to Cm delta T, or from here you can directly find the value of C, which is nothing but Q by M delta T, or you can directly learn it, that is C is nothing but Q upon M delta T, right? Which is the formula of specific heat capacity, right? Okay, next. So now what we have to do is we have to find the value of specific heat capacity. Specific heat capacity. For that, what we need is Q. What is the Q? Q is here heat energy which is required, right, to reach the temperature of any body. So what is it is given already, I think, yeah, 2400 joule. The next one, it is your mass. Is mass given or not? Just check here. Yeah, mass is already there, which is nothing but 50 gram. So what you have to do is you have to take it in SI unit. So first of all, you are going to convert this 50 gram into 50 kg. So how you will do it? Mass is equal to 50 just divided by 1000. Whenever you convert a smaller unit into larger unit, so just you have to divide that particular value by the relation, whatever the relation it is. For example, here relation was 1 kg is 1000 grams, so I'm going to divide it by 1000, right? So it will get converted into kg. 0 will get cancelled out, and from here you will get 0.05, yeah, 0.05 kg. Got it? Next. Okay, now what we are already given in order to raise the temperature to 327 degrees. From where? 27 to 327. So this is T1, this is T2. What is the change in temperature? T2 minus T1. Final temperature minus initial temperature. So final temperature is nothing but 327 degrees Celsius minus initial temperature is your 27 degrees Celsius. So now if you subtract, you will get 300 degrees Celsius. And what I have already told you, that either it is 300 degrees Celsius or 300 Kelvin, it is same. But when it is said about change in temperature, not simple temperature, only in case of change in temperature. So you can easily write it as 300 Kelvin, right? There is another method to find it in terms of Kelvin. So what you can do, first of all, you have to convert this 27 degrees Celsius into Kelvin. So just add 273, you will get in Kelvin. You have to also convert this value into Kelvin. Then you will subtract, you will get 300 Kelvin. That's your choice. Okay? Okay, great. Next. So now, because we have got all the values that we need to find the specific heat capacity, now we are going to just put all these values here. Got it? Now, so C is equal to, what is Q here? It is 2400 joule. 2400 joule. Next, divided by M, which is, what is M here? It's 0.05 kg, right? Multiplied by change, not time, it's temperature. So change in temperature is 300 Kelvin, right? Okay, next. Just you have to solve here. If you remove decimal from the denominator, you get 1 and zeros in numerator. So I am going to write multiply 1 and as well as, because it is 2 zeros, I am going to 1 and double check. Got it? Chaliye. Next what I can do is I can cancel these 2 zeros, then later I can divide by 5. So 5 4s are 20, it's 4 8, then 0. It will become 480 divided by 3, right? So I'm not writing here all units, so I'm just erasing it. At the end I'll apply all the units. Okay, so 3 4, it will become I think 16 times, so it will become 160. How you will write the units? Always remember, either it is heat capacity or specific heat capacity. Keep in your mind how you will write. So in case of specific heat capacity, it is joule per kg per Kelvin. But if you have to find, whenever you have to find heat capacity, then the unit will be joule per Kelvin. There will be no mass, no kg. Okay, got it? Done. So that's your specific heat capacity, and that's we are done with this question. Now let's move towards our next question, which is an electric heater of 1000 watts. So what is here watt? Watt is used to represent the power, which is the SI unit of power actually. So we are given here power. So you are going to write the information which is power, right? So power is 1000 watt. Now next, to raise the temperature of 5 kg liquid, it means again you are given mass which is nothing but 5 kg of liquid from 25 degrees Celsius to 31 degrees Celsius. 25 degrees Celsius to 31 degrees Celsius. So how you will find the change in temperature? T2 minus T1. T2 is final temperature, minus T1 is 25 degrees Celsius, which is initial temperature. If you subtract, you are going to get 6 degrees Celsius, which is also equal to 6 Kelvin. Again and again I am explaining you why, right? Next, in 2 minutes. Also this time we are given time. So now let's say represent this time by capital T, because already we are using small t for time, right? Sorry, temperature. So now we are going to represent that capital T as time. So because it is 2 minutes, so we are going to convert it into its SI unit. So what is the SI unit of time? It's seconds. So it will become 2 multiply seconds, it will become 120 seconds, right? 120 seconds. Got it? Okay. Now what we have to calculate, see, whatever the information were given, just we have put here, right? Now we are going to put the in formulas all these values and we'll get a whatever actually desired value, right? Next, so what is the formula to find heat capacity? Because we need heat capacity. So to find the heat capacity, we need Q by delta T, nothing else. Q by delta T, and heat capacity is represented by C dash here, right? Okay. So it's Q by T. What is Q here? Do you know value of Q? No, you don't know. So first of all, what actually we have done here, we have set our target, because we have written here all the given information. Second thing, we have set a target that we need heat capacity, and to find the heat capacity, what we need? What do we need? We need heat energy. Secondly, change in temperature. We know the change in temperature, you can put here 6 Kelvin, no doubt. But do you know what is heat energy here? No, heat energy is not given here. But it is not given directly, indirectly it is given here. How you are going to find it? Let's do it. So you know, because we are given power. So what is power? Power is nothing but work done upon time, and work done is nothing but its energy, or in this case we will say it as heat energy. We will say it heat energy. Why heat energy? Because here this work done, see, if you are going to increase the heat of any body, you are giving temperature, it means you have to do work done on that particular body. So the work done will be equal to heat energy supplied to that particular body. Got it? Okay. So here you are going to replace this work done as heat. So from here heat will be equal to nothing but power into time. So amount of work done you will do, that will be your heat energy. Now, do you know power? Yeah, we know. It's 1000 watt. Now, what is time? It's 120 seconds. If you multiply, no doubt it will become 12,000, right? No, it will 3 and 1, 4 zeros. So 1,20,000. So it's 1,20,000 joule. 1,20,000 joule, right? Next, you can cancel it 2 times. It will become 2, 1, 2, 3, 4 joule. That's not joule, joule per Kelvin. Sorry, joule per Kelvin. Again, always try to write the SI units of the whatever physical quantities you have found, because if you don't write, if you don't write SI units, you are going to lose your half marks. Got it? Okay, great. Next. So that's this was your numerical number 4. Let's do, there are 2 more numericals. Next, numerical number 5. A bucket contains 8 kg of water. 8 kg of water, right? Okay, so let's draw figure also, so that we can understand very easily. A bucket, there is a bucket, let's say it's a bucket, and it contains 8 kg of water. 8 kg of water, okay? Here it is containing 8 kg of water. Next, it means it is mass. It means it is mass, okay? Next, and it is kept at 25 degrees Celsius. So its temperature is 25 degrees Celsius. Its temperature is 25 degrees Celsius. Now, a bucket contains this much water at 25 degrees Celsius. Next, 2 kg of water at 80 degrees Celsius is poured into it. See, there is another 2 kg of water. This is 2 kg of water, and its temperature is 80 degrees Celsius. 80 degrees Celsius. And this water, it means it is a hot water. Yeah, it is a hot water. This hot water is poured into this bucket. Now, what will happen, and on which concept it is actually based? So this concept is your principle of calorimetry. Yeah, it's concept of principle of calorimetry, where this body, let's say this is your body A, which is hotter, right, as compared to this body. So let's say this is your body A, right, and this is your body B. This is your body B. That's your body A and that's your body B. This is your hotter body and this is your colder body. You can say easily, right? Okay. Now, because we had used the representation as it is your mass M1 as the of the hot body basically, and T1 of the hot body. Similarly, it will be M2 and T2. Got it? So specific heat capacity of this one will be C1 and specific heat capacity of this one will be C2. Got it? And we already know that specific heat capacity in both the cases will be same. Just let me know why. Because both are water and specific heat capacity of water is same, which is 4200 specific heat capacity joule per kg per mole. Joule per kg per Kelvin. Okay, next. So now what we are going to do is just we'll use the principle of calorimetry. It means what we will write here. We'll write here heat lost by body A is equal to heat taken, you can write, or you can say gained by body B. So here body means here we are using just water. Okay. So the condition is also given. Neglecting heat energy absorbed by bucket. It means no doubt there will be some amount of heat energy which is absorbed by this bucket if it is kept in any utensil, and also here, so it is neglected here. Got it? We are just neglecting that particular amount of heat that is absorbed by this bucket. Next, we have to calculate the final temperature. So we know that if it is a hot body, if it is a cold body, if I put this in here, so after some time all the body's temperature will be same. That is called final temperature, which is T. Now we are going to just write the formulas here. So we know that it is M1 C1, and in bracket we are going to write here T1 for this one hotter body, T1 minus T, and for the second one it will be M2 C2 and bracket T2 minus T. Remember this time what we will write, sorry, my mistake, my bad. So it will be T minus T2. Remember it, T minus T2. Remember I had explained you in while explaining the principle of calorimetry why we will write this here, why we will write this here. Go and watch it. Okay. Next, so just put all the, so see here you can cancel this C1 and C2. Let me tell you why. Because C1 and C2 both are here same, and in multiply you can directly cancel them. Both values are same because both bodies are here water. Now just let's put all the values which are given and we'll get the final temperature, which is nothing but T, right? Okay. So see M1 which is this side, it is your hotter body. So what is the value of hot body? In case of mass it is, no doubt it is 2 kg, right? So just put over here 2 multiply C1, no, they are cancelled out. Now T1 is what? Hot body temperature, which is nothing but 80 minus T, right? T we have to find. That is your final body temperature, right? Final temperature of the body. M2 is nothing but 8 multiply T, which is we have to find, and then T2 is nothing but 25 degrees Celsius, right? Second body temperature. Now you can calculate 8 to the 60. So it will be 8 to the 16, 160 minus 2T, that will be equal to 8T minus 25 200. Got it? Okay, just we are going to solve it. It will be 160, this side it will become 200, then 80 if we send this side it will become plus 2T. So 82T it will be 10T, and this side it will be 360. So now if we do so, then we will get final temperature as 36 degrees Celsius. Just let me know, is it clear or not? Done, right? Okay, now let's do the last numerical of this video, right? Let's do the last numerical of this video. Okay, that's your 40 gram of water at 60 degrees. So let me tell you, this numerical is the most important numerical of this video, or you can say